Okay guys, so we are talking about loading constants. Loading constant is actually a problem in ARM because it cannot load constant directly. So to load the constant it uses a different method where it uses the move operations, instructions which I had studied in the earlier of the chapter. Else it uses the load wala thing. Okay, so just see here why ARM cannot directly load a 32-bit constant, because they are just in 32-bit inside. A single instruction cannot encode a full 32-bit immediate constant. So to handle this limitation, ARM provides a pseudo instruction. So what it does, for the solve the problem, it uses the pseudo instructions to load constant into registers. So what are the pseudo instructions? So one is this load one, loading constant and loading the address. Sometimes it uses only the move thing. So here, very simple, load register constant. So load the constant into the register. Loads the 32-bit constant into the registers. If the constant fits within an instructions, it is loaded using move. Otherwise, it is loaded from memory. Just remember. So if the constant fits within an instructions, so within 32-bit, if the constant is within 32 bits, so it is loaded using move. Otherwise, it is loaded from memory. A load address add. So the label address from the label is loaded into the registers. So loads the relative address into the from the label. See, from the label, the relative address is loaded using the PC relative addressing. How constants are loaded? The assignment determines the best way to load the constant. If possible, see, the best way is always this. It is very easy, direct instruction is loaded. Else it has to use LDR or ADR. How we'll see here? Loading a 32-bit constant using LDR. See, you have to write LDR R naught is equals to 0x. So you have leaving these two things. Why? Because for 32, right? So it loads a 32-bit constant into the R naught. This requires a memory access which can be slow. So instead of that, you can use it by using move. What you have to do? See, you have to just two zeros. Instead of all the F, keep it as 0. Just replace this 2 0 with F. See, only 2F. So it will take move not, right? Not means what, it takes the complement of this value. So what is the complement? It takes, see, done. So it's very faster than LDR. It does not require memory access. Conversion of LDR pseudo instructions. So LDR R naught comma 0 is equals to double F. So here usually actual instruction is what happening. Move R naught with number of 0x15. So this is pseudo instruction. This cannot happen. So this is happening. And here actual instruction, load into the register. This whole thing, it wants to be loaded into this register, PC comma offset of 12. So instead of doing that, you can directly do it by this pseudo instruction. How you can use it? So basically it always tries to move or move not if feasible. Else if it is not happening, it falls back to LDR. Okay, if necessary. Example 3, how it is done by using ADR to load an address. Simple. See, add R1 comma label. So whatever the address is there at the label, loads the address of the label into R1. So see, simple. That concludes the first chapter of module 3. So I can successfully put like this over here, and that completes the first section. And now we can move on to the second part. How many are there? So let me just mark 1, 2, see, 3, 4, 5, 6 topics. Looping, mostly they are not that difficult. The second part should be much easier than the first part. Okay, we'll